In our previous examples, we've done questions that look like this question here, but the difference is the number we've been looking for has been in our numerator. So by simply cross multiplying one time, we were able to determine it. This one's going to be a little bit different because the number we're looking for is going to end up in our denominator. So let's start by looking at the shape. It is a right angled triangle, so I know I can complete trig ratios on it. I have an angle of 64 degrees. I know the adjacent side to it. And it looks like I'm going to be looking for the hypotenuse. So according to SOHCAHTOA, which reminds us of the values each trig ratio uses, it's cosine that relates the adjacent and the hypotenuse sides. So they've started this work for me. What they're saying is that the cosine of 64 degrees would be equivalent to the length of the adjacent side divided by the length of the hypotenuse. So the cosine of 64 equals 7.9 divided by a, because we don't know the length of the hypotenuse. So just like we did in the last few examples, we could cross multiply and bring that a up and multiply it by the cosine of 64 degrees. Now up until now that was enough to get our answer, but we actually are solving for a. So there's one other step I have to do, and that's to isolate the a. I have to divide both sides by the cosine of 64. So I have to take this term now and divide it out so that the a is left standing by itself on the left-hand side of the equation. Now, the suggestion here is to do all that isolation and just punch it in your calculator once. So the length of the hypotenuse is going to be equivalent to 7.9 divided by the cosine of 64 degrees. So I'm just going to grab my calculator and I'll move it over. I start by going 7.9 divided by, and just use your cosine button, 64 degrees, and of course I'll close my bracket there. The number that I get is representing the length of the hypotenuse. So to the nearest tenth would be 18.0 units.